Pass me the sound chip we bought from eBay. Play the welcome. Oh no.
All your bass are belong to us.
Welcome to TexElec Tech Tales. I mean Tech Tale. Hello, Kevin from TexElec here. A few recent videos were published on YouTube discussing gray market sound chips. We read through many comments and received quite a few questions regarding the use of these chips, so I decided the best approach was to make a video covering the topic in more detail. Nearly all of the parts we use in our products are still manufactured and readily available. We purchase most of our parts from Mouser Electronics or similar retailers. If parts are out of production, we seek old stock via sites such as octopart.com. Sometimes, out-of-production parts are priced reasonably, but other times they can be very expensive or simply unavailable. I believed most hobbyists knew of gray market chips and their need to use them in certain situations. The YM2151s, unfortunately, are almost certainly refurbished parts. For others, it's not always easy to tell for sure, but I'm jumping ahead. Allow me to explain what gray market chips are, why we use chips like this at times, the steps we take to mitigate issues, and why using the term fake for these chips is not entirely true. While they can be a little worse for wear, the chips we're using are almost certainly still Yamaha ICs. Before I get into the details, I want to address a more obvious question some may be asking, which is why even use the YM2151 or make an ISA card for a vintage PC using one? There was never a card manufactured in the past using this chip, so software support is pretty minimal. When we first started TexElec, I wanted to build DIY products and other products for vintage machines that weren't just clones of other projects. I really wanted to design products which never existed but maybe should have. Like many other electronic hobbyists, music has also been an interest of mine for some time, and as it turns out, some of my first songs ever were made on a YM3812. Here's a terrible one now. This led me to design our first sound card, the ReSound OPL3. I knew the OPL3 was OPL2 compatible, so it would instantly have support for any ad-lib applications. And while reading the YMF262 datasheet, I learned that the OPL3 actually supported a 4-channel output mode. So we built the world's only 4-channel OPL3 sound card. Now I had the bug to build more sound cards, which leads me to the next major bit of sound research, which was for the Commander X16. Initially, I joined the Commander X16 project to design the audio section, but later I went on to design the motherboard as well. But that's actually a whole other story. David Murray really wanted to use the AY3-8910 sound chip, since it's simple to write code for, like the Commodore SID. We didn't have the full specs ironed out for the machine yet, but later we realized the AY3 was just going to be too slow for our bus. As the designs changed further, in truth, we could actually support the AY3-8910 now, but that too is another story. The Commander X16 has several design goals, key of which is to use as few programmable logic devices and microcontrollers as possible. It is meant to be simple, socketed, and use as much traditional logic as possible. We did violate this rule with a video card for various practical reasons, but for sound, we had options. When computers first started making sounds, single-voice square wave was king. However, later chips, such as the SID, SAA-1099, AY3-8910, and the SN76489 could generate more complex sounds and add them together. These are also known as programmable sound generators. They have a fixed set of programmable oscillators, filters, and mixers to generate sound. While programmed digitally, the output is analog. FM synthesis is a little more difficult to explain, but essentially it works by taking a primary sound source and modulating it with another one, or perhaps many. This can create complex additive sound forms. While I don't believe Yamaha invented the concept of FM synthesis originally, they certainly are the most known for its use. As time went on, the ability for CPUs to play back digital audio increased in the late 90s. Nearly all sound cards that supported OPL2 or OPL3 by this time were doing so by emulation and samples. Slowly, developers moved to generating their own sounds and soundtracks with external sound hardware, and simply would trigger wave-based playbacks at the right time for their needs and code. While this means you can literally insert any sound you like, modern sound devices no longer actually generate sound. They really only play it. Therefore, no one, including Yamaha, still makes classic-style sound-generating chips. They are obsolete and have been out of production for over 20 years now. For the X16, we opted for one programmable sound chip and one FM chip. I did a ton of research on many YM series chips, and the YM2151 stood out because it was fast enough for our needs, and it is the most capable FM chip in the series. The SAA1099 is also the fastest and most capable PSG-style chip. However, they are only available in quantity from the gray market. This was the case with the AY3 8910s we tested as well, so we decided to pursue it further. I began buying chips from several vendors to test them out. By this time, the first prototype motherboard for the X16 was complete. I built both the YM2151 and SAA1099 adapter card to test, and we were able to get them successfully working on the prototype. Unfortunately, at the time, we were unable to save or load on the system, so I was never able to easily write code to stress the chips to my satisfaction. I also wanted to make sure I had the analog portion of the design handled for the X16, so I built a prototype on a platform that I'm actually quite familiar with, the Isobus for the PC. Thus, the SAM card was born. The chip gray market can mean many things depending on who is asked, so here's my definition. The chip gray market is a place where parts are sold by unauthorized retailers. These parts may be legitimate, fraudulent, or completely misrepresented. On one end of the spectrum, some parts may be completely legitimate, but the retailer simply lacks an agreement with the manufacturer to sell them at retail. On the other end, the parts are completely fraudulent and not even what they have printed on them. These parts may be built with a similar package and disguised to appear as a more expensive part. There are many shades in between as well. I've personally attempted to buy many parts over the years, such as CPLDs, FPGAs, various types of RAM and ROM chips from these vendors, and very often the chips would simply not work or have a failure rate of 75% or greater. I've been building electronic projects most of my life, and this has been an issue for at least the last 15 years, if not longer. As a result, I rarely if ever buy a chip which is still available for new from gray market retailers. Sound chips have proven to be quite a different story, however. Before I dive into that discussion, I want to discuss the differences between counterfeit, replica, fake, and refurbished ICs. To start this discussion, I decided to look up the definitions from the Cambridge Dictionary for each term. Counterfeit, made to look like the original of something, usually for dishonest or illegal purposes. Now, it's fair to mention that the dictionary does mention this as a synonym of fake, but for the context of our discussion, it's slightly different, and I'll explain more in a moment. Replica, an exact copy of an object. Fake, an object that is made to look real or valuable in order to deceive people. Refurbished, made to look new again by work such as painting, repairing, and cleaning. And the last definition I wanted to throw in is from definitions.net. New old stock, refers to obsolete equipment or original parts from obsolete equipment that have never been sold at retail. It has been sitting on a stockroom or warehouse shelf for some time. Counterfeit chips are chips made to emulate the original function of the device in question. For jewelry or money, the goal would be to convince someone it was original so they would pay an inflated value for it. In the case of a sound chip, however, it would have to actually make sound to convince someone that it was legitimate. It may not be 100% compatible or feature complete, but it would be enough potentially to convince someone that it was real. While there were many sound chips on the market at times which would use samples to play back OPL2 or OPL3 type sounds, even these chips are technically not counterfeit. They're really more on par with emulators. What's truly important to note is that I am not aware of the existence of any counterfeit Yamaha chips. This means no one has attempted to reverse engineer the original hardware of the chips, build their own die, manufacture their own, and then sell them as original Yamaha chips. The amount of complexity and expense to do this would be very prohibitive. There are simply much juicier targets for counterfeiters. Replica chips are designed to be exact functional copies of the original, but are not advertised as the original. In some respects, there are many replica chips available now for chips such as the SID, and even some of the YM chips in the form of FPGA cores. However, these devices are running code to do emulation and are not emulating the true hardware. To my knowledge, there is no replica that has been designed to use die-level hardware. Just like the counterfeit chip, it would be prohibitively expensive to build an actual replica. Emulation is probably good enough for most folks. Fake chips are units which have been altered to look like the product they are advertised to be. The common approach would be to find a cheaper part which is similar in physical appearance and modify it by painting or etching the surface to alter its numbering. These chips are usually quite easy to detect, as they simply don't work. While this seems to be a huge factor for some parts, in my experience, it has been less of a problem for sound chips. Refurbished chips are probably the most common sound chip available now. While the process does look rather gruesome, there is a very large recycling market in China, as well as other countries, to strip components from disused electronics and recycle them for reuse. Many times, these chips are reconditioned to make them appear newer than they are and unused. To be clear, I do not approve of this practice, but the fact remains that it may be the only source for some parts which would just simply otherwise be unavailable. Bear in mind that this means the chips are in fact legitimate Yamaha chips, not fake or counterfeit, but an original Yamaha part in a reconditioned state. New old stock chips are chips that were never used but may have been sitting for many years. Today, any remaining Yamaha stock which fits in this category would be at least 20 years old. While these would certainly be the ideal chips to source, getting large quantities for a decent price is often not an option. As discussed earlier, I spent several months testing many sound chips from various vendors. Much as reported in other videos, I experienced roughly a 10% failure rate. The good news is that normally when these chips don't work, they usually fail right away. This makes it easy to isolate bad chips, but I wanted to stress the chips more to see how they would hold up over time. The first ISA prototype board was built around 3 months ago, and shortly after making a brief demo video, I left this machine running most of the time. I periodically plug in a speaker to see if it's still playing as it should be, and so far so good. While I know this is a sample size of a whopping 1 chip, it's not the only testing we perform. It's just an experiment I thought would be interesting. Since we sell many vintage PC cards, I have several computers set aside for testing purposes. We test all of our products, and the SAM card is no exception. It's also fair to mention that our ReSound uses OPL3 chips, our RadLib uses OPL2 chips, and we've been selling those for a number of years now. While I understand that the performance of these chips is no guarantee for the YM2151, I did test enough to the point to where I feel like they're probably going to work at the same rate. So I'm sure many people are still asking, well, why not just find parts from old stock if you can? Well, as it turns out, when we can, we do. For example, it's actually not too difficult to get a hold of a legitimate YMF262 OPL3 chip. The 3812 OPL2 is a little more difficult, and from the videos it seems that the YM2612 Genesis Megadrive chips are a pretty mixed bag as well. As for the YM2151, I actually did look online, and this is what I found. The first place I'd always like to check for parts is Mouser Electronics, and I know it's a huge long shot that a chip like this will be available here, but I always like to take a look. But sure enough, no, nothing here. Another site that's a decent place to look is octopart.com. It's actually a search engine that looks for various old stock retailers out there and checks their inventory and will give you a nice list of it. There are actually several services which do this, but most of them seem to search the same inventory, so Octopart's usually a pretty decent source to go to. And let's see what they have. Oh my. Well, there are 2 vendors that stock it. Dana Microsystems is actually not one I'm familiar with, but I do know Quest, and look at that. 6 in stock, $60. Wow. In my experience with these vendors, the prices are pretty much the same across all of them, give or take $1 or $2. I believe they work from a database that shows the price of old parts, and they all pretty much more or less have the same price. Well, anyway, for $60.66, let's take a look at the actual price of my SAM card. Oh, $72.99. And another thing that people probably aren't aware of is that there actually is a second chip which is required to use the YM2151, and that's the YM3012. Now let's go ahead and take a look for this part on Octopart. And there we go. $17.50. So not terrible, but still decently expensive. But let's take a look on eBay for both of these. So let's look at the YM3012. This chip was probably a little bit more prevalent because it was actually used with multiple YM series chips. That one looks suspicious. So there's actually Italy, UK, China, 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 UK for one. So you probably can get these chips legitimate, and it's possible that even the ones coming out of China might be legitimate as well. But now let's look for the YM2151. And I'll sort low to high. Okay, so there's your first one. And more than likely, these are going to be gray market chips, just looking at the price. But it's difficult to rationalize paying $60 for one for a card that is only going for $72. The only real option I would have would be to make it quite a bit more expensive, and it would be a very limited number of stock. And furthermore, once we start using this chip on the Commander X16, it's going to become even more difficult to source the numbers we'll need. So let's take a look for one more sound chip, which I know a lot of people look for, just to kind of illustrate a point. The SID chip. Well, not Commodore. Let's try MOS. Nope. What about the 8580? Yeah, that's not the correct part. So definitely not. Well, I think we all know we're not going to get them off of Mauser, so I'm not even going to bother. And let's just go ahead and take a look at the Commodore, let's just say MOS 6581 chip. That's kernel. Don't know why those are coming up. There's one, $37.77 from Canada. $70, $80. Huh. But what do you notice? There are none from China. And of course we have the swim SIDs. There's UK, Germany. So, places where the Commodore 64 was popular, it's not surprising. But look at the prices, $60, $61. Cheapest I found, $37, plus shipping. So let's look at the 8580. Oops, wrong number. Likewise, $80. So there are no remanufactured Commodore SID chips. There are no counterfeit Commodore SID chips. They don't exist. And likewise, I would say that the Yamaha chips that are on the gray market are in fact really Yamaha chips. They've just been remarked and relabeled to disguise the fact that they're pulls from old boards. And while I'm not totally in favor of that practice, the reality is there just simply wouldn't be that many of these chips left without doing this. That's why the SIDs are so expensive and scarce, because there's no way for them to salvage a sufficient number of them from old boards. Unlike the Yamaha chips, which were on tons of arcades, game consoles, places where they're actually more accessible in Asia, whereas the Commodore 64 just simply was never very popular there. So should the card just not exist? I realize that these chips may not be for everyone. In every community, there are purists and functionalists, and I always was a function before fashion kind of guy myself, so it was never a large concern that the chips weren't perfect. What is important to me is that they are really Yamaha chips, and I have no reason to believe otherwise. We've discussed this topic many times within the Commander X16 community, and about 20% were concerned with this, and 80% were excited to have access to these chips. There certainly is a risk in using them, but we do our best to mitigate that with careful and time-consuming testing. Without these chips, some of our products would be very expensive or simply impossible to produce. The intent of this video was to be as transparent as possible about our development and construction process. We felt it was important to point out that there's a little more to the story of so-called fake chips. And with all that said, please accept our apologies if you feel you were misled by the use of these chips on our products. It certainly wasn't our intention to do so, and we hope this squares up our position and reasoning for doing so. Thanks for watching, and we really appreciate your time. Hey, and if you have one more minute, I just wanted to show one quick demo of our SAM card playing a VGM file. I went out to vgmrips.net, and if you're not familiar with vgmrips.net, it's a great site where you can go and listen to arcade music. It actually plays it right on the website, so you can hear pretty much what it should sound like. I'm not certain what the engine is behind the emulation, but best I can tell, it's pretty accurate. So I just went out and found a song that'll work on the YM2151 sort of at random. And what I found here is Blaze On. It's actually not a game I'm familiar with, but I found this song that I thought was kind of neat, and it's the Stage 2 Cosmic Ocean Blue. So I'm going to go ahead and play this on vgmrips.net first, and then I'm going to play it on the actual SAM. And here's the SAM hardware playing the same song.